Hello, everyone, and welcome to Temporal Summer Camp 2024. My name is Mason Egger, and I am a senior technical curriculum developer here at Temporal. And today I will be your host for Show and Tell. So, if you are wondering what Show and Tell is, we have three presenters who are going to be doing some amazing, quick little lightning talk style presentations on temporal related topics for us to learn and just hear about their journey using temporal. So we're going to do those really quickly, and then we'll have time for Q&A. So if you have any questions, feel free to put them in the chat, in the comment section through the streaming platform you're viewing this on, and we'll be able to bring those questions online and we'll be able to answer them. So great to have you here. Let me know if you have any questions, and without any further ado, let's go ahead and bring on our first presenter, Nuno. That is not the way I want that. That's better. Hey, Nuno, how's it going?
Hey, everything good? How are you?
Doing well. You want to do a quick intro for yourself? Tell us where you're coming from and where you work.
Yeah, for sure. So I'm Nuno. I live in Porto, Portugal, and I am the tech lead at CoreFlux.
Awesome. And looks like today you'll be presenting on building an orchestration engine with Temporal. So I'm going to go ahead and leave the screen and leave it to you. Best of luck.
Perfect. Thank you. So today I'll be talking about orchestration and building an orchestration engine with Temporal. And it's probably a good idea to start with the why. So what do we do at CoreFlux? We are an IoT company, and we develop solutions so that clients can build their IoT data pipelines from end to end. We started with the edge, so you can imagine in the IoT market, there would be something like manufacturing. And so clients have factories where they have to connect multiple devices. And so we built the software so that clients can communicate with different protocols and streamline it to one very popularly adopted protocol, MQTT. And we stuck with the edge and the self-host narrative for quite some time until this year we decided, hey, we should probably go to the cloud and offer the benefits of basically zero effort setup for our clients with our own cloud platform. And so that's the challenge we set to accomplish. Now, of course, that came with a lot of problems, we can say. One is the simplicity we offer to clients, of course, means someone else needs to handle all the challenges. And in this case, that would be us. So what were some of the problems we dealt with when building the services that would allow us to build this cloud platform? So we were dealing with distributed events from billing events so that we trigger the creation of our client's cloud resources to the actual deployment of those services. There's a lot of events and they are being produced by distributed services. And that creates a big issue that we need to solve somehow. We also had the issue of asynchronous execution. When you are creating cloud resources, you often need to wait for a certain resource to be created before creating the next one. And this often happens with multiple resources at the same time, whether that is resources from one client or multiple clients. And sometimes you even have interdependencies of workflows that were already running. And so that was one of the biggest challenges we had and that we needed to solve somehow. And then we also had the question of state management. So we need to ensure that for all given steps, the state is up to date so that we can reference it between workflow steps. And also from a DevOps perspective or a platform engineering perspective, we had all interest in being able to define all of our infrastructure as code. And so being able to handle all that was what we set to do. Now, it was not easy, I can say. We started with a very clunky solution just to get it out there as soon as possible. And that was to use a quick service that would create a Docker container where we would run some, or we would apply some OpenTofu configs. And that was pretty simple, pretty straightforward to do, just so that we could get it out there. And that's how we were able to launch it in a fairly short amount of time, like a month or so. But they had a lot of issues, which are all of these basically. State management beyond the OpenTofu management of state with the state files. And if you're not familiar with OpenTofu, OpenTofu is a fork of Terraform, which you might have heard of, and that facilitates, or it allows you to define all of your infrastructure as code, and it will ensure your infrastructure state is idempotent. So as long as the inputs for applying that config are the same, your outputs will be the same. And so, yeah, we were able to handle those state files with OpenTofu just right. The problem was actually managing state between steps. We had a very specific challenge, which is since we are deploying services which have TLS, we need to make sure those certificates are issued before we try to start the service that requires those certificates. And so that was one first issue we had to deal with, which was somewhat complicated. And then we also had the challenge of the service being very slow, because if you're just starting Docker containers for everything, it becomes very slow. Asynchronous execution was definitely a challenge. And so we also had to scrap that architecture. Distributed events, initially we sort of handled that fairly okay, because we have our own MQTT broker, and MQTT, if you don't know it, it's a pub-sub communication protocol. And pub-sub is the perfect architecture for distributed services, in my opinion. And so we sort of handled that okay, but it could be done better. And so after 3 months, we redesigned basically the whole architecture, and we did so after coming across Temporal. And so how did Temporal come into this solution? So the initial part of the events, how they're produced, how services are subscribing to them, that's the same. What really changed is, instead of executing OpenTofu configs or applying those configs within Terraform containers or Docker containers using OpenTofu, we actually embedded OpenTofu into Temporal workflows. And so now we had OpenTofu aware Temporal workflows, where we can make sure if a workflow failed for some reason, that we could easily restart it and recover state from the state file, or even from memory. And we also were able to much more easily distribute things like credentials using our secret management infrastructure. And so Temporal really made it possible to build this orchestration engine without having to reinvent the wheel, because we knew we had an orchestration problem. We could either adopt technology that would help us solve that, or we could do it ourselves. And when we came across Temporal, it was an obvious choice. So I think that's basically it. I'd like to get some questions now. So thank you.
Awesome. Really cool to hear about people using Temporal to do infrastructure as code work. I've been pretty interested in that. So I haven't had a chance to play with OpenTofu yet, but so I know it's a fork of Terraform. So do you just use the Temporal event history to save the workflow state in the event history and then just pull it back down? Is that how you're accomplishing that?
Well, there's two sides of it. We have one of the sides, which is actually the OpenTofu. When the OpenTofu execution finishes, it saves a state file, right? Mm-hmm. And so if we need to pick a new workflow using the same state file, we will just reference it. And we are handling all the configs in a way that's reusable for any type of module, basically. It's not like we have to code every boilerplate thing for a workflow. We have the structure to be able to reuse it. But when a workflow fails, and so the state file would be lost from the completion, what we do is we essentially are not we are not recording the state from an individual point from module to module, but rather which steps we completed. So we have a workflow, which is to create an MQTT broker on our cloud for our clients. And that's 9 temporal activities. So that's 9 steps, right? And so if the workflow fails on step 3, we'll use the retry and we'll sync it from the event history, and it will just force the state from the previous state. And that's how we were able to handle that. In case a step fails, we're able to retry it.
Awesome. And then how are you invoking OpenTofu from your workflows? Is there like a CDK? Are you like shelling out and just running the CLI tool from the workflow?
You mean calling the workflows from Temporal or executing OpenTofu?
Executing OpenTofu from within the workflow.
Yeah, we're not shelling out, but we're just doing syscalls to be able to run the CLI. Yeah.
Okay, awesome. Yeah, this was something I've been curious about for a while. So like I was curious as to how people are doing it. So it's really awesome that you got to come on and give a presentation about it. So that was great.
Yeah, we found a pretty great experience doing this with Go, because we're able to very easily take care of concurrency even when doing syscalls. And so we reached a pretty good result where on one temporal worker, we were able to execute 200 concurrent workflows, which is pretty great.
Yeah, that is pretty great. One last question, I guess I'll ask: what was like the biggest like oh, that's weird, or challenge point that you had when you were developing this? Like what didn't behave the way you thought it should when you were originally working on it?
Well, we could say there was one pretty obvious mistake that was made, which is, hey, let's start with Python. It'll be quick. You can just redo it later. It was a bad decision, because who would use Python for a completely asynchronous execution model, right? It's like shooting yourself in the foot without even starting. And so I can even say it was like a weird, unexpected thing. It was more of, it went wrong before I thought it would, right? So that was one pretty obvious mistake that was made.
Can you even invoke system calls asynchronously in Python? Like,
no, I mean, probably there's someone that's very skilled in async.io or some other library for asynchronous execution in Python that's able to do it. But the way we were doing it with Python, which gets even worse, is actually we were just creating new Docker containers to basically every, let's say, workflow you're running, it would be a new Docker container executing your temporal module with a shell file for the entry point of the container. So you can imagine how slow it was.
Yeah.
Yeah, that was a pretty bad architecture. But hey, it got the job done for some time, and we were able to cut the lunchtime. So
hey, Python is really good at getting the job done for the time. And as my old boss used to say, there is no discernible difference between a proof of concept and production code. So there's so many proof of concepts running in prod. So awesome. Well, thank you for coming on, Nuno. It was great having you. Yeah, it was awesome.
Thank you. It was a pleasure.
Awesome. Cool. And next we're going to bring up Lauren. Hey, Lauren.
Hey, how's it going?
Doing well. Cool. So why don't you go ahead and just quickly introduce yourself? Tell us what company you're working from, and just a little bit of information.
Absolutely. Hey, everyone. My name is Lauren, and I'm the co-founder and CTO of Ampersand. So Ampersand is a developer platform for SaaS integrations. And what I mean by that is our customers are using us to build integrations between their B2B SaaS app and their customers' other tools. So an example could be if someone is creating sales tooling or marketing tooling, their customers already have their existing data living in systems like Salesforce or HubSpot or Zendesk. And instead of building those native integrations in-house, they can use us for reading and writing to and from their customers' tools. And we built all of our integration code on top of Temporal. And today I'll dive into a little bit of how that works. So should I get into it?
Yeah, let's go.
Okay.
Good luck.
Awesome. Part of what we're doing, as I mentioned, just to give everyone a little bit of context before we dive into the architecture, is we are both reading and writing as our core, two of our core actions. And today I'll mostly be focused on the read part of things, and write. I'm happy to answer questions about it, but it works pretty similarly. So the first thing that happens in our system is our customer creates a new integration, and one of their customers hooks up one of their tools, like one of their Salesforce or HubSpot instances. And that's what we call a new install. So when a new install happens, we have to kick off a scheduled read into that system. So we use temporal schedules, which has been really great for us because it gives us really fine-grained control over both the interval as well as gives us tools like pausing a workflow, restarting one, triggering one on the spot, and the tracing around it within the temporal dashboard has been really helpful for debugging. So this purple here is our workflow code, and we do a couple of things in this piece of code. So first, we have a database table where we are storing the state of each read. So each of our individual end customers have their own row in this table, and we're storing things like what was the last successful read that we did? Were there any pagination tokens that we are currently in the middle of paginating through? Is there any other cursor that the API returns to us that allows us to pick up next time where we left off? So here's where the read state is being stored. And the first thing that happens in this workflow is we're fetching the latest read state from the last time we did a read. Once we have that and understand that and make sure this read state is not error, because sometimes we'll have OAuth issues where that token is expired, in which case any future reads will fail anyways. So we will just want to early exit it and not try. Once we confirm everything's in order, everything looks good, we'll start making calls to the third-party API. And here we are usually having to paginate through because usually these records are pretty voluminous and we can't get it all in the same API call. So we're doing this loop where we're getting a page, next page token, we're paginating through this API. Eventually we'll get some kind of a signal from the API itself that we're at the end. And then that's when we do a data transformation step instead of the temporal activity. And once all of that is done, we pass it to another service on our side. We use Kubernetes, so this is another Kubernetes deployment for us. We call it a messenger, and this is what eventually will notify our end customers that this read is done and pass them the data. And this is a temporal schedule. So it is, and each customer has configured their own schedule. And that's another great thing about temporal schedules is each one we can attach a new interval to. So every X minutes, this looks different for everyone. This will come alive again and do the same operation. A few things I just want to point out here. The first is that error parsing should really be first class. And this is another thing that we really like about temporal is that we can differentiate between retriable errors and errors that we should just give up on it and not retry. And we have alerting built off of these different types of errors also, especially the non-retriable ones. So that's first thing is, error parsing code, very important to make use of the different classes of errors that temporal supports. The next thing that we found really helpful is custom search attributes. So if you haven't used these before, Temporal comes with a number of default search attributes where you can look up workflows, and you can also add custom ones. And when you're launching these workflows, you can attach these custom search attributes. So this is an opportunity for us to attach things like an operation ID, which is what we use for debugging on our side. We can attach customer IDs and a bunch of other metadata that makes it easy for us to debug down the road. And thirdly, temporal schedules have been really awesome to work with. So prior to this, we were actually using temporal cron, and that, while it worked for us, was much more limiting in terms of what we can do. And making the migration to temporal schedules has been definitely worth it, and been really helpful for reducing the amount of code we have, and for making it more maintainable and operatable overall. So that's a quick high-level overview. Happy to dive into any of it.
Fantastic. Thank you for that. Really interesting use case. I also like temporal schedules. I've heard of a lot of people building a lot of really cool things on temporal schedules, so it's a fun little thing to build. Couple questions. So when you were originally trying to figure out, like when you were evaluating temporal, like did you go looking for temporal? Did you know temporal existed? How did you find temporal?
Yeah, so I knew about the existence of Temporal. I was listening to an episode of Open Source Startup podcast, and one of the Temporal founders was talking about the product and the journey, and I thought this was the exact solution that we would have needed. So I didn't really go around evaluating many other alternatives as a result, and we got onboarded onto Temporal Cloud through the startup program, and that was a great process because we were able to get pretty hands-on help, and we were pretty it was a pretty smooth journey of implementing, and we kind of just went with it after that.
Awesome. Yeah, the Temporal startup program is pretty cool. It's a fun program. Let's see. Do you all run one workflow with activities? Do you do any like cross workflow communication, like workflow to workflow, or is it all just a singular workflow?
So we have multiple workflows mapped to the different API interactions we support. So what I just talked about is our read workflow for scheduled reads. We have another workflow for our writes, and that one works a little differently because it's mostly for bulk writes. So the third-party APIs, instead of paginating through, is more of an interaction where we create a job, and that third API does an asynchronous job. We then have to pull on that job to get its status. So those are our two primary workflows. And each of these workflows have sometimes contain more than one activity. So for the bulk write workflow, for example, we have one activity that kicks off the job and makes sure it gets launched successfully, and then another activity that then pulls on it, and that activity sleeps and then calls itself again. So then we are polling on that operation, I believe is every minute or so, where we're kind of doing that polling again until it becomes successful. Awesome.
That sounds really cool. And then I guess the same question I asked Nuno at the end. What is one of the challenges that you face when implementing your workflows? I always love hearing about the where people get messed up. As a curriculum developer, I write a lot of the content on like how to unstick people when they get stuck. So I like knowing where people are struggling because it tells me what I need to work on.
Yeah, I think one thing that took the team a bit of time to really wrap their head around is what becomes a breaking change in Temporal. So there's been a few times where in the beginning we made modifications to the workflow code in the input, especially in the parameters we're expecting, because it's in our code base. We typically don't think about having to change a parameter within one of our own methods. That's usually not a big deal. But in Temporal, because we've got this external dependency, and workflows are expected to be replayable, and they're expected to be idempotent. There's these things that you just don't think of right away when you're writing code, and that when you're touching temporal workflow code, you have to be very careful about. So just educating the whole team on what is a breaking change, what is not backwards compatible. When we do make those breaking changes, how do we roll it out safely has been a bit of a journey for us.
Yeah, I know we I helped wrote some of the temporal courses here, and we cover that very much in Temporal 102. The changing
okay.
the temporal command.
Taken 102.
Yeah, the non-deterministic errors, which is always a fun one to deal with. So do y'all, when y'all update your workflows, are you using workflow versioning and things like that?
We haven't. We've so far not made too many updates. And what we have done is essentially start up a new queue, and just transition that way.
Yep. That is so we have so many courses. We have a versioning course, and that's one of the methods that we do recommend, is that you could do, we have mechanisms inside Temporal to do versioning, but you could just easily spin up another queue and then basically drain the old queue, and then your problems are gone. So
yeah, it does involve you having to come up with new names for queues, but because we haven't done it too many times, it hasn't been too big of a deal.
Does it like old file names on a desktop, like q2.backup.temp? Like,
we try very hard not to name them that way because that would get too confusing.
Awesome. Well, thank you so much, Lauren. It was great to have you on. And I'm going to go ahead and bring on Daniel. Thank you. Any last words?
No, just enjoyed using Temporal. For those listening, I highly recommend it.
Awesome. Thank you so much. Before I bring on Daniel, it's time for a word from our sponsors. And by sponsors, I mean Temporal, because we are our own sponsor. So if you are participating in the Temporal Summer Camp this year, we have the Temporal Coding Contest. So this is an opportunity for you to kind of get a chance to get your hands dirty with Temporal. It's a programming challenge where you print the letters of the alphabet, but how weirdly can you find a way to do it? How over architected? If you've ever wanted to over architect something, this is your opportunity. I think we had someone who submitted as a submission to this where they did something with activities to generate heat maps on the CPU to spell out the alphabet. Okay, so you definitely should be looking to do this and have some fun with it. You can also find it on the Temporal blog. You can just find announcing the Temporal Summer Camp competition. So you can always find that on the blog. Thank you, Karine. And yeah, so that's it for that. I'm going to bring up our next guest, Daniel. Hey, Daniel, how's it going?
All's well.
Awesome. Good. Tell us where you're from and where you work.
Yeah, so I'm from California. I've been a founding engineer in my company, AutoKitty, for the past year. Prior to that, I've been developing, managing large-scale infrastructure systems in other companies such as Google, Datadog, things like that. And yeah, today I'm going to talk about the wonders of AutoKitty using Temporal.
Awesome. Well, I will let you have at it.
Cool. So, hi everyone. AutoKitty is a platform that you can use to build durable workflows in just a few lines of code very quickly. It's an open source platform, so you can download it today from GitHub. If you want, you can install it on your personal computer, on-prem, and we're also working hard to launch a cloud platform very soon. Basically, you can think about AutoKitty as a platform that executes workflows. That's not surprising. It's using Temporal under the hood. That's also not surprising. And the advantage in using AutoKitty is that it simplifies the workflow that you have, not the technical code, the workflow that you're running, but rather the work that you're investing in order to make it work. So a common challenge with Temporal would be, well, I need to learn about the subtleties of how to deploy workers and what is the difference between a workflow and an activity. And this is something that we try to abstract away from the user so that they focus only on the logic that they need to implement. You can think about that like kind of Zapier for developers. However, you're not limited to a specific subset of recognized and supported triggers and actions, and there is no upper bound on the amount of time that a workflow can run. At its core, AutoKitty is sort of serverless in the sense that once it's installed, you don't have to manage its infrastructure. It is self-contained, and it makes sure that its own infrastructure is working correctly. As far as your code goes, using AutoKitty, the deployment model is very simple, but it also provides a lot of versatility. I hope to touch on that a little bit later. the code that you implement and you deploy is very simple. It uses Python. By the way, AutoKitty itself is based mostly on Go in the backend, and we have our own front end as well, which is TypeScript and other things. But what we've discovered from our users is that unless they really want to have the advantages of higher level languages like Go, they would prefer something that they're familiar with, like Python and JavaScript and TypeScript. However, an interesting critique that I heard earlier today was that you don't want to develop production code with something like Python usually, and that is usually correct. In the past, I've worked in YouTube. I can talk for hours about the pros and cons of developing a production platform in Python and then rewriting it completely in a different language, but that's not the topic today. The point is that with AutoKitty, all of the considerations of, okay, how do I do asynchronous things? How do I provide backups? How do I synchronize remote databases? All of these things are gone. Another thing that is important is, in order to simplify the code, we also provide a lot of API integrations out of the box. So another common challenge for Temporal users is that when they know that they want to integrate with some well-known service like Slack or Jira or Kubernetes, they have to implement their custom worker that encapsulates their understanding of using that SDK and the common journeys with that SDK. So this is also something that is more or less abstracted away, and you can use the well-known libraries on the internet directly. We also provide secret management, so you don't have to inject all of the API keys and tokens on your own and manage them securely. Rather, we are doing that for you. And on top of that, obviously, there's monitoring and logging, which is required for any modern platform. Again, at a high level, you can think about AutoKitty as a set of temporal workers, and that is an abstraction that works really well. You have your workflow management and monitoring, which is done in a very similar way to Temporal. But as I said earlier, we also provide out of the box a lot of integrations that many customers are interested in various use cases, which I'll explain later. That includes, by the way, both outgoing API calls from your workflow into the service, and obviously getting the response back, but also incoming asynchronous events, which are handled in a robust way and then dispatched to any relevant subset of running workflows, as well as triggering new workflows in order to run. As a user, what you would do with all that construct is basically write your code in a very simple way, and you can use either our CLI to manage that code and deploy it, or you can use a Visual Source Code extension that we have. And as I also mentioned earlier, we have a cloud platform coming really soon. Oops. Yeah. And as I said, you write your code, you set up your project on the AutoKitty server, you initialize some connections, you deploy your code, and then you just monitor the execution and you see how sessions are running, what is failing, what is not, and all the usual debugging magic that you have with Temporal as well. A bit about deployment. So I mentioned building, I mentioned deployments. Just to clarify what that means, if you have a package of files or modules, code, data, assets, resources, you can define that as your build. That build gets packaged, linted, and pushed into the AutoKitty server in the context of your project. Within that project, you have abstract execution environments, one or more, and within them, you have deployments of these builds. So you can have either a very simplistic view of that world where you say, I want to push a button and I want to see it deployed. and I don't even want to think about any running sessions that are currently in progress. I want to drain them slowly and see that happening. You can also think about more advanced rollouts like blue-green deployments, rolling deployments, things like that. It's the simplicity or complexity of that is entirely up to you. Now, there's a vast array of use cases that you can use AutoKitty in, and I think there are a lot of similarities with other presenters that we've seen so far, where you can think about GitOps, deployments, FinOps, all the ops, basically. More specifically, as I said earlier, if you think about it like Zapier for developers, you define a set of simple triggers like a Slack message has been triggered, a command, a Jira ticket has been opened, a PR got a comment, and then your workflow is a set of actions and side effects that happen as a result of that. And also, by the way, another trigger is obviously scheduling. You can basically use all those API integrations that I mentioned in order to interconnect a lot of disconnected systems, whether they're DevOps systems, back office systems, whether that means deploying your product in multiple environments across multiple repos, maybe even requiring some manual approvals in the middle. You can monitor financial systems and do some cost saving with recurring monitoring of things like GitHub Copilot, for example, in removing seats, automatically assigning user seats where necessary, things like that. Here's a specific example of a snippet of code. I want to show it not because it's amazing, it's because it's very, very simple. What you see here is just very simple code that opens a Google spreadsheet, reads it, and returns a map version of it. And the only thing here that is unusual, the thing I marked here and I highlighted, is this single function which we provide, which essentially initializes the spreadsheets, the Google Spreadsheets client for you. Behind the curtains, it retrieves the secrets that you used, that you configured in order for us to use, and it returns to you that open source public client that everyone is familiar with. So if you wanted to write your own client code unrelated to Temporal, and then you just want to use the Temporal goodness and inject it into this script, that is roughly how you would do that. Another slightly more interesting example is ChatGPT. Again, there's just one thing that is unique to AutoKitty here, where we initialize a client object for you. But again, that client object is the regular, popular, open source client that anyone uses anywhere without any special customizations or wrappers that that the user requires. And you can do anything that you can do with the that API. And yet another simple example, this is Botto 3. It's the AWS API in Python. And this just shows a scenario where you ingest events and you also do some paging, because there may be hundreds of events and not just 25 like you would assume in your testing environment. And last but not least, just an example of an incoming hook where you say, okay, whenever there would be some kind of HTTP request, whether it's GET or POST, depending on the content type, etc. Here's what I want to do. And in this example, I think we're creating a Jira ticket, for example, which is just a single function call. Now, this would be very similar looking to people who use Python to just Flask code. But again, the difference is that Flask requires you to manage the server, manage the infrastructure, handle outages, whereas in this case, all of this is taken care of for you with AutoKitty and Temporal. And I mentioned earlier secrets management, and I just wanted to clarify this is a very important deal here because you no longer have to save those keys as environment variables or something like that and make sure that it's not stored as a file somewhere or pass it securely. This is something that we do for you when you configure a connection to one of these things, and you can also do it with OAuth, so there's no key involved. But another thing that contributes to the simplicity of AutoKitty scripts is that unlike regular workers in Temporal or workflows in Temporal, where you're essentially running the entire workflow as a single unit of code in the runtime engine, whether it's Python, Go, TypeScript, whatever, what we do here is basically inject into the code structure all the hooks and all the automation that Temporal uses. So you don't have to write, oh, this function is an activity, this function isn't. Rather, or this function has this type of timeout and retry policy. This is something that we inject into the code automatically. And yeah, that's about it. This is the QR code for Discord. If you're interested, you can log in and we will be happy to help you with trying this out. There's still rough edges, obviously, but we hope to make this public, as I said, as a cloud platform very, very soon. And anyone who needs any help about that is welcome to ask any question.
Awesome. Thank you for the presentation, Daniel. Yeah, I guess I have a few questions. So are you building, like, for all of the different integrations, are you like, so say like you have the integration for, Google Sheets, are those built as like activities and you're composing workflows of activities? Or what's like the high level overarching architecture of it?
Yeah, that's a good question. So the usual approach with Temporal in many organizations is that you wrap an SDK or an API with a worker, meaning that for every function that you want to be using in your workflows, you have a function for that in your worker. What we do is kind of the inverse of that, where our worker is actually deconstructing your regular Python script. And when you're using their any kind of function call, which isn't like a standard library call, then we wrap that with our own activity. So as far as you're concerned, you're using the standard open source client for any kind of service. But from our perspective, we are ensuring that it has all the goodness that Temporal provides.
Awesome. That does sound pretty interesting. I guess, what are some of the challenges that you faced when you were building this? Like, what's some of the pain points you've dealt with?
There are many, but I have to say that at least as far as Temporal goes, that was kind of the least of our problems. An interesting part would be things that are actually pretty much solved, but not all obvious or trivial. So versioning in workflows is not really a problem for us, but versioning, because our workflows are kind of self-contained and sort of immutable if you squint at it, but you do have a lot of power when you want to version aspects of our platform. And scheduling is also a challenge which was solved very nicely with the new scheduler from Temporal. Then there's the question of passing data, for example, which has been a challenge for a long time, but is also pretty much solved, where today you don't have to build your own layer on top of Temporal that passes data references and you keep that data in a separate database. Rather, you can use the data converter, which is and things like that. Or you have Temporal Cloud, which allows you to forget about setting up your own Temporal server locally and run that. All these things.
Yeah, that definitely. The data converters are pretty cool. I've done a little work with them, and they're a really neat thing. I haven't heard of any. I know people are using, but you're the first person that I've talked to that's actually mentioned like using like custom data converters to solve that problem. That's a really interesting thing. I'll have to look into that. That sounds fun. Okay, but we are going to bring on our other two presenters for a final, just kind of like quick little roundtable kind of discussion. So I'm just curious if anybody who presented has any questions for any of the other presenters about what the work that they've worked on.
Yeah, I guess I do have a question for Daniel. So, what do you basically, from what I understood about Aurakiti, it's trying to do, of course, it's trying to build the abstraction so people don't have to worry about the temporal specific things and they can just focus on just completely coding their business logic without handling infrastructure, right?
Yeah.
And so, while being able to use any open source library client and take care of the and have the advantages of temporal. And so, one thing that is curious is maybe it's even a question for both of you, which is how do you manage when you need to update a workflow? Because you need to register them there in your workers, right? And so how do you handle that? I maybe understood a way you're doing it, but I just want to confirm. So how are you guys doing that?
So before Lauren answers, I'll say what we do in AutoKD. I kind of touched on it briefly and said that our workflows are immutable if you squint at it, and I want to explain that thing. So when we run a session in AutoKD, basically a workflow in Temporal, that workflow will run to completion. That can be after a second, 5 minutes, 2 months, a year. That doesn't matter. But once it's running, we do not allow its code to be modified because we don't expect that workflow itself to change its function. However, the abstraction that we built on top of that, which is AutoKD builds, is exactly that. It's a different version of your code running in a separate pool, whether you want to think about it as a separate temporal queue or not, that doesn't matter. And so that first queue is still running as long as you want it to, and it is guaranteed to stay the same, but it will no longer get any new sessions starting, any new workflows. That will go to that new queue. And so you're basically getting a draining situation. And if you want to stop by force those old sessions, you can, but that means you no longer have to deal with version checks in the code during runtime.
Yeah, okay, that's interesting. But when you do deploy new versions, so you drain the old queues and you create a new queue, let's say, regardless of the details, it's a different pool for your workflows. When you do that, you need to register them with the worker, right?
Yes, but that is
So you restart the worker, or so you automatically restart the worker where those are registered, or?
Yes, it depends on what type of change you're talking about. So if you're talking about change in the user code, that does not require any changes in the worker. If you're talking about changes in the AutoKD server, then yes, that obviously requires restarting the server. Obviously, that actually doesn't impact running workflows because thanks to the guarantees that Temporal provides, they will just start from that same point where they stopped. So that's not an issue. And again, you can do that in a rolling fashion where new versions of the AutoKD server with its workers are accepting all the new workflows and the old ones are slowly winding down. And another thing, as far as user code is concerned, is that when you deploy that new version of your code onto AutoKD, if there are no running sessions for that old deployment, then it is automatically deactivated. It is only in a draining state as long as there are running sessions, because we don't want to stop them on our own without the user's permission or their oversight for that.
Yeah, I guess the question comes from, with temporal, you can't by default dynamically register workflows, right? You started your worker with your default workflows, you register them, and if you want to change it, that would be changing your worker code, right? And so I guess my question is, how do you dynamically register these new workflows with your abstraction, basically?
So it's actually not dynamic because changes in the workers are actually changes in the AutoKitty server. The server itself is partly the workers. So changes in that would mean redeploying, rerunning the server itself. So by definition, that means that we're shutting it down and starting it back up.
Okay, yeah, got it.
Lauren, any thoughts for you?
Sure, yeah. So I think we have a similar model, which is when we have new customers integrating different APIs on top of the Ampersand platform, that does not require a new workflow to be registered. So we have a single workflow that handles all the reads, and we've basically built an interface for how reads are described so that we can represent any kind of APIs using this single interface. And when we give it a couple of parameters, so this basically allows us to not have to register new workflows when new APIs are integrated.
Yeah, okay, yeah, makes sense. Are you using gRPC for that or some other framework to build those interfaces?
So we're using Go also. So I was just describing kind of like a Go interface that we have a connectors library, which is open source, where there's a set of input parameters you put in, and then it conducts the API call underneath the hood. And our temporal workflow calls out to our open source library using this read params interface that we've defined in there.
Oh, okay, yeah, makes sense.
Yeah, I actually have a question for you, Nuno. Given you talked about the transition from Python to Go, I'm curious at what point did you throw in the towel and do the migration to Go, and how was that process?
Well, Python was definitely never a definitive solution, but when we threw in the towel is when it got so complex. The point of doing Python was, yeah, let's make it quickly because it'll be easy, right? When it started getting unnecessarily complicated to build something so simple, such as a synchronous event handler, that's when I gave up, basically. Like, if I was doing this with Go, sure, maybe starting this or the start would be a little bit harder because we were starting from scratch. We had no like tooling for the cloud. It was completely made from scratch, and so it would be a bit harder. But actually, writing Go, it's pretty easy and pretty simple, right? And so we ultimately gave up when it was more work to do the hacky solution than if it was to do the real solution, let's say.
Got it.
Awesome. We did have a question come in from the chat that says, hello, what are the best practices for long-running activity workflows? Say my activity is running for hours and days. So I think like everyone here has mentioned that they do have long-running workflows. So what's some advice y'all can give around long-running workflows?
Yeah, so temporal heartbeats is really useful, where you can make sure that if there's anything that happens with your worker code where it goes down or there's a redeploy, using a heartbeat allows that temporal to be able to reinvoke that workflow at the point that you left off. So that's like number one. Another thing is if there are times where you need to sleep or pause your workflow, instead of using a system sleep method, use temporal sleep method. That would be my two recommendations.
Awesome. Nuno or Daniel?
I mentioned versioning earlier, which is really important when you consider that you don't expect your workflow to finish quickly. So you may definitely have to change something there during runtime. So be aware of that. But other than that, I would say the experience I've seen before using AutoKitty while I was using Temporal in its neat form was that it was surprising how much DevOps work had to go into the workers. So basically, there was a lot of need to watch for memory management, resource usage for the workers themselves if the long-running workflow was misbehaving.
Yep. And then I think one of the other things is making sure you're setting appropriate timeouts. So if things do fail, you can detect them quickly. So a lot of people will just say, well, why don't I just set my timeout to infinity? It's like, well, timeouts are one of the ways that Temporal detects failure. And if you the whole point of the retries is to detect the failure and retry. And if you set timeouts that are not appropriate for the activity that you're running, then you're going to, and you're not heart beating, because you could set a longer timeout if you're heart beating and then act upon the heartbeat. But some people will set the timeout and not add the heartbeat, and then wonder why their thing is stuck. And it's like, oh, because it broke 2 seconds into execution, but you didn't give it a long enough heartbeat, or you didn't give it a long enough timeout to detect that things actually went down. So we're actually working on an error handling course right now that's going to be coming out later this year on everything you ever wanted to know about how temporal errors happen, and timeouts and heartbeats and stuff are a big part of the course content. Okay. We are nearing time. Does anyone have any last words they want to throw in before we hop off? If not, it was wonderful to have you. A few things to talk about before we go. Temporal's Replay Conference is happening in Bellevue on September 18th to the 20th. So if you would like to come and meet me in person, or come take the courses in person, or come learn about Temporal from a whole bunch of people, you can come to Replay, and there's a promo code here called Webinar20, which will get you a discount on your ticket. What other stuff? We have other summer camp things that are happening. So tomorrow we have an AMA with Max, our founder. So I will be hosting that. So if you want to come and ask Max questions in the chat, please come and ask our founder some of the questions, and we have some pre-selected ones too. So we'll have a really good conversation. And then on Thursday, if you're curious about how to learn Temporal, my other colleagues. So I'm one of 4 curriculum developers on the education team here at Temporal. My other colleagues will be doing a presentation on all the different ways you can get started learning Temporal, some of our favorite resources, and some of the content and stuff that we've created around that. So we have our AMA tomorrow with Max, who's our CTO, and you will be able to come and just watch it again. So if no one else has anything else, it was great getting to meet all of y'all. I hope to see you at Replay, and if I don't, I'll definitely see you around in the community. And if you're curious about summer camp stuff, you can find more about what's our program at summercamp.temporal.io.
Thanks so much for hosting us, Mason.
Awesome. It's great meeting all y'all. We'll see everyone next time.
Bye.
Bye.